Energy cannot be destroyed. It is transferred from one form to another. When an object falls, it loses its gravitational potential energy, G.P.E, and gains kinetic energy, K.E. This is known as mechanical work. The speed of a freely falling object increases very quickly. It accelerates at nearly 10 meters per second. The G.P.E stored by an object is at its maximum height, and its K.E is 0 because it is not moving. When the object falls to its rest, its G.P.E is at its minimum and has been transferred to its K.E, which is then at its maximum. The mechanical energy is the sum of the G.P.E and the K.E. The G.P.E depends on mass, height, and the gravitational strength of the planet that the object is on. The K.E depends on its mass and its speed, velocity. In this experiment, a falling object is simulated by dropping a card from a known height. Its speed is measured just above the ground before it lands. First, a straight line is drawn across the middle of the card. This helps to identify the exact height that it will be dropped from. Then, the mass of the card is measured and recorded. The meter rule is attached against one stand, and the light gate is attached to another stand towards the bottom end at 0.1 meters, 10 centimeters above the tabletop. The light gate is set up to measure a width of 0.05 meters, 5 centimeters. The pin is attached at 0.2 meters, 20 centimeters, horizontally with the tabletop using sticky tack. The middle line of the card is aligned with the pin, so to minimise the rotation and air resistance as it falls. The card is dropped 5 times. Each time the speed values are recorded in a table and the average speed is calculated. The height difference between the light gate and the pin is also calculated. The kinetic energy is calculated using the equation, a half times the mass times the speed squared. And the change in gravitational potential energy is calculated using the equation, mass times gravitational strength times height. The height of the pin is increased by 0.01 meters, 1 centimeter, to 21 centimeters. And the card is dropped from this new height 5 times. This is repeated for each additional height increase of the pin, 22 centimeters, 23 centimeters, 24 centimeters, 25 centimeters. The average speed is calculated for each set of results, and from this the Ke and G.P.E can be determined. A graph of change in G.P.E versus Ke is then plotted once all data points have been recorded or calculated. The change in G.P.E is almost equal to the gain in Ke. The gradient of the graph is almost 1 and the y-intercept is almost 0. When the piece of card is let go, the gravitational pull starts doing some mechanical work on the card, transferring some of the gravitational potential energy into kinetic energy. Just before it hits the ground, its gravitational potential energy is almost 0 due to almost 0 height. Almost all the stored gravitational potential energy has been transferred into kinetic energy. The kinetic energy of an object depends on its mass and speed. By finding the speed of the card just before it hits the ground, its kinetic energy can be determined. G.P.E is transferred during the fall into Ke. In this investigation, air resistance was negligible. Therefore, the gravitational force transferred almost all available G.P.E into Ke by doing some mechanical work. It is assumed that all the change in G.P.E is transferred into Ke. The energy transfer can be mathematically shown like this.